Just had a very interesting question posed to me. What if you have a piece of music and it says Maelzel's metronome quarter note equals 80? Well, how do you know how long the piece of music will be? All right, so you have this music sitting in front of you and you're given this metronome number, all right here at 80. So how do we create a formula from that? Well, first we're going to go ahead and convert that 80 into seconds. So what we do is, I have other videos out on my channel about how to do this, but the time in seconds is equal to 120 divided by 80, or each revolution of that pendulum, okay? Pendulums are always rated in RPMs, not beats. And that's 1.5 seconds. So knowing that, then we say that, well, if your time signature is 3/4 time, you know the quarter note gets each beat per measure, right? So there's 3 in, say, 3/4 time. So that would equal 3 beats per measure times the total number of measures. Okay, therefore, you take let's make Maelzel's metronome equal to M, L equal to the length of the piece, T equal to the 3 in the 3/4 time signature, and then the number of measures, make that equal to N. Well, you get 2 formulas. Actually, you'll get 4 formulas out of this. The first one's in seconds. So if you want the length in seconds, take 120 times T times N divided by M. And if you want minutes, then you go ahead and take the length in minutes equals 2 times T times N divided by M. Now, if you have the length of the piece, but you want to know its average metronome length, just swap the 2 out. So put M equals 120 Tn over Ls, or in the lower equation, M equals 2 Tn over the length of the piece in minutes, okay? Quadrant demonstrandum, so that's how it's done. And you can go ahead and play with that formula. Again, you'll need to know the amount of measures of the piece. You'll need to know how to read time signatures. You'll need to know which note gets the beat. Now, not everybody's a musician, but musicians will know what I said. And if they're familiar with how the metronome is read, then they will do this correctly. Now, this happens to be what we call whole beat metronome practice. This was the practice in time of the invention of the metronome till a couple of decades later, when for some reason they turned it into this single beat theory idea. The problem with it is that it's not always usable. So there's some single beat readings that cannot be played physically. And even if they were, they sound so fast that it doesn't even make sense. And we know from the historical documents of the time that say, for example, vivace was actually slower than allegro. This we know from Dr. Thomas Young's work called the Essay on Music that he published in 1800. So we know vivace was actually slower than allegro. Again, without all this tradition, most musicians who play these works of the time are pretty much lost. I get it, because I had teachers that taught me by tradition. They actually didn't go into the history. They didn't teach me how fast Mozart's music might have been and whatnot. So if you want that single beat theory number, then what you'll do is for the minutes, you'll just reduce that 2 to 1 on the lower formula. And on the upper formula, take the 120 and just half it, take it to 60. And you'll have your single beat theory number. Again, this gives you actually the whole beat metronome practice based on how physics determines the length of time in seconds for the length of a pendulum. Okay? Quadrant demonstrandum, like, subscribe, share, enjoy, and go ahead and practice this on a few pieces. Write it in the comments and tell me what pieces they are, the numbers you used, and I'll verify. See you later, guys.